Hello and welcome back to our series of videos on the topic of solids in contact. In our previous videos we were looking at how to locate the extreme generator of solids and how to locate points on individual solids. So in this video we're going to look at how to bring solids together and how to add one solid to another so that it's going to be in contact with it tangentially. So we're going to first of all begin by just looking at what we're trying to do. So our question here is how to place a solid in contact with a cone and the horizontal plane when we know the radius of the sphere. And for each of the questions that we're going to look at in this video, we already know the radius of the sphere. We'll have other videos dealing with how to locate a solid if we don't know the radius to start with. Just looking at the question, one thing I'll point out is that we're placing a sphere in contact with a cone. When we say that in contact, what we mean is we mean in contact tangentially. So that means that it's in contact with it at one point and one point only. It's not digging into the solid itself. Also, we'll just look at what the horizontal plane, if you remember your orthographic projection, the horizontal plane represents this plane here representing the ground, basically. So that's what we're trying to achieve. We'll just look at a couple of background principles before we get into that. And the background principle we want to look at here is just how to locate the point of contact between a circle and a line. So the example we have here is a football, and if we look at a case of a football on the ground, well, the center of the football, if we were to drop a line down like so, that would locate us the point of contact, the single point where our football is in contact with the ground. If we were to look at that a little bit closer, instead of saying straight down, really the relationship between the ground line here and this line here is that it's perpendicular, because the line that we have here isn't always going to be horizontal, so it's better to try and get the relationship between the two. So it's perpendicular. Likewise, the relationship between the center and our line here is that it's the distance of the radius off of the ground, so from our basic maths. Also, I want to look at what happens if we kick this ball and if we roll it along the ground. So you can see, if we were to trace the path of our center, it seems to take this line like so. Again, each point on this line is the distance of the radius off of the ground, so that any position that we have our football along this line is automatically going to be in contact tangentially with the ground. Also, if we look closely at the two, instead of saying that it's going straight across, it's better to say that it's parallel with the ground line. The reason we try and establish these relationships such as perpendicular and parallel is because that we don't always have to have a horizontal line. If we have a sloped line like so, we can see here's our center point and here is our line perpendicular to our slope line this time. Likewise, if we were to kick him along the sloped line, you can see the path that it's going to take is parallel with the slope line like so. So it's better to give the relationship between the objects rather than just saying straight across or straight down. So that's just a little background principle that you'd be familiar with from your tangent topic. So we're going to put that into practice then in this question here. Here we have the 3D representation of what we're trying to achieve, and here we have the cone set up in elevation and in plan view of our object. So what we're going to do is we're going to solve for each of our components individually first of all. We're going to start off by solving for our sphere in contact with the ground initially. So we're going to begin by just taking our XY line. We're going to draw a line perpendicular up, and we're going to measure up the radius of our sphere. So for argument's sake, we're just going to say this is 20 millimeters, just to give it a figure. You'll be given the radius in the question before you start. So we come up for our 20 millimeters here to draw in our sphere out to the side at the start with, and we kick him along and we roll him along the ground, giving us this parallel line. And you can see I haven't stopped the line at this point here. I've just continued it on because at this point we don't really know where this line needs to stop. So, but we do know that every sphere of radius 20 millimeters with its center on this line has to be in contact with the ground, or horizontal plane. So we've done that for our sphere in contact with the horizontal plane. Now let's do the same thing for our sphere in contact with the edge of our cone. So, and in all the examples in this video our spheres or our solids are going to be in contact side by side with each other. We'll have another video explaining how to roll it around towards the front of the object. So as we did in the last with the horizontal plane, we're going to come off with a line perpendicular out 20 millimeters, and we're going to roll our sphere along the edge. So where the two paths cross at this point here is going to give us the location for our sphere that's in contact with the edge of our cone and the horizontal plane, which is what we're trying to achieve. So that's our object like so. To find the point of contact, we're going to draw our line perpendicular to the edge of the cone, and that locates as our point of contact. So that's our front elevation solved for our two solids. We're then going to bring it down into our plan view, so by dropping our center point straight down, and we're going to take our extreme generator across. And if you remember from our video on extreme generators, because the two are side by side, we see the outline of our cone here. We know the outline of our cone here is along this line from the center, straight across from the center. So this is our point, giving us the location of our sphere. And just to show you as well, if you look at the hidden detail here, some people are surprised when they start off, why aren't the two solids appear just to be two circles just touching at one point? Well, because there's an overlap. Because this is a cone, this solid here is leaning in over the base of it, so there is going to be this overlap like so. The last thing we need to do then is find the point of contact in our plan view, and we do that by just dropping our line straight down, and again, because it's on the edge of our cone here, it's going to be on the extreme generator in our plan view. Again, a very common mistake. A lot of students when they begin try to put it on the outline of our two objects. So, and again, if you're in any doubt about it, maybe go back to the video on extreme generator to explain that. So that's our solution for our cone and our sphere. We're just going to fill in the rest of the object, just so this is what you're going to see, and just take away maybe the color. So this is what you're going to see on your sheet without any of the shading. So that's for a cone and a sphere. The next exercise we're going to look at is what to do with a sphere in contact with an original sphere. And again, we do know the radius of the two, and our new sphere is going to be in contact with the horizontal plane, like our last example. So, like the last example, we're going to just look at how we locate the point of contact. So if we take the example here of two pool balls, here we have the center of each of them. The point of contact is located by simply joining the centers of the two, giving us the point of contact, and we label that with POC, point of contact. And make sure you always label your points of contact POC. So, like in our last example, we're just going to take a closer look. We can see the center of this sphere is the radius away from our point of contact, or the edge of our original one. And as we would kick it or maybe roll it around the original object, we can see the path it takes this time is going to be a circle. So the circle, the radius of this circle is the original circle plus the radius of whatever our second circle or our second sphere is. So that's our background to finding our points of contact and being able to trace our path of rolling one around the other. Like in our last example, we're going to put that into practice here. So here we have our original sphere like so, and here we have our setup, what we're trying to achieve in 3D. So like in the last example, we're going to start off by breaking it up into individual parts. We're going to solve for the sphere first of all, so we're going to place our new sphere, again we'll say maybe radius 20 millimeters, so come up 20 millimeters here, and we're going to roll him along the side, so that we're going to trace the path of our center. So if we draw a sphere of radius 20 millimeters anywhere with its center on this arc here, it's going to be in contact tangentially with our original sphere. So we've done it there for rolling around the sphere. We're going to do the same as we did the last time, rolling it along the horizontal plane, and with the two cross gives us our common point. So that's our common point in elevation. Like we did in the last time, we're going to bring it down to our plan view, straight across from our center, giving us our location in our plan view. Again, you can see there, because we're dealing with a smaller sphere here, there's going to be hidden detail where there's one sphere is going to overlap into the other one. Last thing we need to do now is find our point of contact, and with our point of contact, you always want to find your point of contact where you see the two spheres edge on edge, side by side first of all. So this is going to be our front elevation here. Join center to center, locating our point of contact here, and like in our first example, we're going to bring it straight down, and again on our extreme generator, because it's on the outline, the outer edge here in elevation, it's going to be on our extreme generator here in our plan view. So that's our point of contact there. And like a question there, we can see it in 3D. And like in the last exercise, we'll just get rid of the color here just to give you an idea. This is what this is going to look like on your sheet. Now, our next video is going to be showing you how to solve questions like this, but how to roll them around into a final position then afterwards. So, as always, stay tuned to the rest of the videos for more, and thank you very much.